the same SUV, the same slope, right? The same amount. It's just that you're answering 3 different problems. You're not answering 3 different problems. Okay, you're not. Okay? So let's try to draw it. Let's try to draw it. I know when the numbers get really big, you get, you kind of like, oh, they're so big. So remember, we know the slope. Oh, what is the y-intercept in this case? 30,000. Yeah. So the equation isn't hard. So in a problem like that, the equation is not the problem. It's understanding what those numbers mean from an SUV standpoint. Okay? Math means nothing if you cannot use the math to actually solve a problem. I always tell young people that, right? You can do all sorts of problems, but if it doesn't solve a problem, solve something that is useful, right? I mean, there are people who like doing that. They are mathematicians. They love doing like proofs and really dig in. But for most of us, we like the math problem to mean something, okay? To mean something. So now, if I have to draw this, I'm not going to start with 0, 1, 2, 3, 4 because that graph would be like way over there, okay? So maybe for x, what should I start with? Well, x is years, so maybe x is okay to be 1, 2, 3, 4. Did you see that?
Yeah.
So knowing like how you put the graph together, I will always put this down so that I remember. So x is years, and this is dollars. All right. So that helped me figure out what I need to do. So x will be years, so I can go 0, 1, 2, 3, 4, 5. Let's just do that. Okay. You know that the value will, what is the highest value for this problem?
30.
You know, right? You know that the intercept is 30K. That is gonna, in real life, cars never appreciate, they depreciate. So I know that I can start here and maybe call that 30K, right? And then maybe if this is 30, I could say this is maybe 15K here, maybe 10K here, 5, right? Something like that. 20, 25. That seems reasonable, right? That seems reasonable. All right. So we know that the slope is negative 5,000 over 1. So do you think the line will be this way or this way?
This way.
That way.
That way, right? Because it's not going any higher. All right? You know that it's a negative slope. Negative slope means that when you move for a certain number, it actually is going to go down, not go up. Right? So I know that the line has to go this way. And I know that it has to cross here. I know that. So how do I know where it crossed? How do I do that? So for every 5,000 that is up, there's one.
You go down.
Okay, you go down one. So if I start with 0, this is a point, right?
Yep.
If I go 1, I lost 5,000, right? So the point is right here. If I go to 2 years, I lost 20, and then so on. All right? So the question is, where is it going to cross? I may not draw this properly. Where is it going to cross where how many years later would the car be worth nothing?
6.
Where did that come from?
5 divided by 30.
So every year 5, every year 5.
Every 5 years, exactly.
That too.
Yes. So without even algebra, you know that logically, right? If you go down every year 5,000, well, I got 30,000 to start with. At the year 6, I will be 0. So right here, right? I actually do pretty well,
You said 5
right?
divided by 30.
Right? Or you could think of it this way, right? If 5,000 is to 1, think about it. Then what is 30,000? What is the bottom number? Right? If 5,000 is to 1, I have 2 times 6. So then this is 6. Right? So that's another way to think about it. This is the year.
That's what I thought of.
Yeah, this is the year, and this is the, it's a negative, right? The value, the decrease in value, right? Or lose value loss. losing
Well,
value,
you
right?
can
You're
think of
losing value
if
here.
you're
Right? So if you look at 5,000 to 1 is the same as 13,000 to 6. Okay? So that's the slope. That's another way to look at it. So therefore, if I ask you what is the y-intercept, it's 30k, right? What is the x-intercept? By the same token, what does x-intercept mean?
Where does it cross on the
Where it
x-axis?
crosses on the x. So where would that be?
6.
6. Okay? And then if it asks, what does the x-intercept mean in this problem? How would you explain it?
When the value of the car becomes 0.
Yes. Got it. Yeah? Or you could say, but what value is it? What does 6 mean? Say that more even clearly. What does 6 mean?
Years.
The number of years when the value of the car is 0. Okay? So again, it might say something like, it gives you 5 sentences, and you choose the one that is incorrect. I don't know, right? There are so many questions I can ask on this one. There are so many problems I can do. Does this make sense? So in another way, algebra, when you put it into a problem that is real life, it's actually easy to understand. Instead of trying to remember the x and the y, the rise and the slope, it actually makes sense. Okay? It actually makes sense. You know, the way you talk about it, it makes sense. For every year, I lose 5,000. That's the slope. That's the slope. It's a relationship between the value and the year. And that's what fractions are. That's why you're doing a lot of fractions, right? That's why you're doing a lot of like isolating y. Okay? So the idea of algebra is really very real life. You guys use a lot more algebra than you think. Okay? When you start talking stuff like, you know what is the break-even point where, you know what, I really cannot owe any more money. When you start talking like that, you are doing algebra problems. Because you're trying to figure out at what point it's like, oh, I can't owe any more money. If I owe some more, I'm going to lose everything. Right? When you start making those decisions, you are doing algebra. You might not do it with an equation, but you are doing it in your head to say, if I do this and I do this, you know, if I go another year, what is my mortgage? If I go 3 years, what's my mortgage? Or my loan, like if I pay off in 30 years versus paying off in 10 years. Right? All those calculators that you get online, they are all algebra problems. They are all algebra problems. Okay. Now I know some of you have been taking breaks, so that's good, because I didn't give you a break. So, you know, you guys are adults, you can take care of yourself, all right? So is this helpful? Just to understand. So now when you read the problem, you kind of go, oh, so it's just saying that, how do I put this problem in mathematical terms, and then be able to explain what all these numbers mean. That's what they're doing, okay? In real life, in a test, it will be more asking you the question. What is the original value? Or what is the value of the car after how many years? Or what does the intercept mean in this problem? Right? What does the y-intercept mean? What does the x-intercept mean? There are like 10 questions, at least, that you can ask in this problem.
So we basically have to do a lot of process of elimination.
Could be, yeah. Partly because you don't have a lot of time, right? But understanding the slope and the intercept will help you get to the answer.
Just thinking about that part.
Right?
Process of elimination.
Understanding that will totally help you and go, oh, it couldn't be this answer. Right? If something say, if a problem say, oh, I'm losing $30,000 a year, you kind of go, no, that's not what that means. Right? That's not what that means. But that requires that you understand what those numbers mean. Right? It requires that you understand that. So understanding that equation, that linear equation, is so key. So key. It's one of the kind of like, if now you can do this, you can tell people, I actually know some algebra. You actually do. You actually do. Oh, this kind of problem, these linear equation problems are classic. They are classic. Okay? For elementary, we may not ask you to think of a relationship that look like this. Oh, okay. We should throw some of this away. We should throw away some of those. So, you know, they are really, oh, okay. Let's throw that about that.
Well, the funny thing is that we must have just
So for elementary, you are likely going to do most of your problems that are linear. Because when your mind is young, you can think about things that are like constant. Like, if I do this, I will get this. If I do this, I'll get this. But as you learn about algebra, in real life, a lot of things are not so linear. Okay? For example, when we start talking about profit and loss, they start looking like U's. Because at a certain point, maybe the other U, right? If you think about it, it might be the other way. It means that you can raise the price up to a certain point, and then all of a sudden you're going to lose money. That's what that kind of graph means. Like learning how to understand those graphs without any number. Huh?
Incremental uplifts and break-even point and then.
And then you drop, right? Right? There's a point of diminishing return. That's what that is, right? I'm going to keep going, and then all of a sudden I'm like, okay, I can't do it anymore, right? And then it's go the other direction. My energy just went the other direction, okay? This is what we talk about the exponential, is that it is so steep, it gets steeper and steeper and steeper. So those are relationships that are different kind, but that's why the test only asks that you know this kind. I'm pretty sure that the test only asks you to know this kind. If they have anything with square and cube and stuff, it's actually asking you to like rearrange the, like simplify, maybe simplify the terms. But I don't think there will be any question that asks you those things. It's only linear equation. Okay, because we are saying that for all teachers, whether you're elementary or otherwise, understanding that is fundamental to understanding relationships between two variables. Okay? No matter what you do. Social science need to understand that. Okay? Like, yeah, there are things that change us that cause something else. Right? The economy, they talk about relationship between the price of the product versus, I don't know, GMP or something, right? There, all those economics terms require that you understand about relationships.
Is there such thing for teachers to like continue to improve with math, that there's like classes offered for like elementary teachers? Because I think it's heavy to carry the weight of
Yeah.
like, I'm not only like responsible to know this for myself, but then also like 20 to 30 kids every year for 45 years.
That's right.
You know.
How many years? Yes.
Like that's like a heavy thought.
It is a heavy
Like,
thought.
this is like a building block for them.
I bet we could do a grid about that.
Yeah.
Yeah,
So
right.
so when you go to a
Like
district,
slope.
when you ask, when you go to a district and ask for a job, whether it is at your school level or district level, you want to ask those questions. What are some professional development for me to improve my mathematics skills? Both teaching of the mathematics, also the content of the mathematics, right? Those are two different things. Just because you know the content doesn't mean you know how to teach it either. Like, I know how to do it, but I don't know how to explain it, right? So you need to learn both. Like, both the content of the mathematics, you want to keep getting better and better. Like, wow, 5 years ago, it took me forever to understand it. Now I'm getting better at it, right? But then now I learned how to teach it. What are ways to explain it? What are problems that I can help explain it, right? So those are some things that you want to ask your district or your school and say, are there professional development for that? There is a national organization called, and you might get a lot of resources from that, NCTM.org. N standing for National Council for Teachers of Mathematics, and it's for K-12, all right? So there are resources that say, oh, I teach 3rd grade, let me click on 3rd grade and see what kind of problems I have, okay? The local one is called MCTM. I guess I could now. The local one is MCTM, and that's the Minnesota Council for Teachers of Mathematics, and they have conferences. And when I was teaching, actually at Metro, I took a group of my elementary teacher candidates to one of the conferences. And it was very helpful because you're like, wow, I learned a lot from other teachers. I learned a lot from people like, this is the way I taught this class, or these are the ideas I have for teaching X, Y, Z. Or combining social studies, like I'm doing butterflies, I'm making this up. And then I'm gonna do a math problem, I'm gonna combine that, right? I'm doing science, how do I make that combination with math? Or I'm working on polling, I'm working on the voting, right? How do I make that into a mathematics problem? So you get to go to sessions and listen in. When I go, I usually get a whole bag of resources, ideas of how I can teach better and learn better. So those are professional organizations that you can look into. But I would say make sure you ask the person that hired you, right? To make sure, because I think that's a great point, because nobody knows this 100% all the time. So you got to keep, bettering yourself, get better and better. And it does get better. And the new ways of teaching math, you sometimes look at it and go, wow, I would have never thought to teach it this way. The more brain research that we have done, we talk about how students learn multiplication differently, people learn adding and subtracting differently. And sometimes we have to be very open and say, well, I never learned it this way, I just do it this way. Be open. Because once you learn multiple ways of doing it, you realize that every kid likes something very different than maybe you. I like this way, you realize that, wow, this kid consistently likes to draw it out. And that's okay, until they get comfortable. You don't want to say, there's only one way to do this multiplication, and that's it. You want the student to have multiple ways of looking at it. So it requires that you as a teacher don't get stuck at like, this is the way I've learned it, and that's what you're going to all learn it, okay? And really look at the book. Some of the textbooks now have many different ways of teaching, like multiplication. I don't know about you. Nowadays, kids learn multiplication by looking at area. That makes sense, right? Then you have a visual way of looking at multiplication. This is 4, this is 3. So it's the same as counting rows of 3 4 times. So there are ways of looking at multiplication that make sense for kids. And some kids will always draw it to make sure they got it right. It is a little longer, but if that's what they are comfortable, after a while they want to do it again. It's almost like a little, what do you call it? Like what is that term? Your blanket? What is that called? Like your security blanket. They keep wanting to draw it to make sure they get it. But after a while, they're going to be fine. Okay? So sometimes students are going to learn at different rates, and you don't want to say, well, you are faster, you don't have to do the drawing anymore, and you are slower, so therefore, no, that's okay. That's okay. They will get it. If you give them a lot of practice, they will get it. But it's a little security blanket, just to draw it and say, did I get this right? Now, did I get this right? All right. Where do we want to go? We have about an when do we end again? 8:45? 8:45. I don't get up till 9:30 usually by the time I train up. So, what would you like? What would you like to do? Do you want to try some problem in geometry first, or you want me to do a couple of problems on there? I just want you to see, want to know where you want to be. Yeah.
I have a
Oh, is that the review? So there's some review, right? Algebra review. What is 7 times 5? Sure, right. Aha! So what do you want to do? Do you want to try some of the... Now, if it is review, maybe you want to do it on your own, right? So if you want to maybe start with measurement, and so measurements, basically you're talking about converting stuff. 1 foot is 1 yard is 3 feet, right? And oftentimes, if they are very simple, you need to remember it. But some of it, they'll actually give it to you. So, like understanding like kilogram, like kilo always means 1,000, like K is 1,000. So kilometers is 1,000, right? So if I ask you, how many meters are in 2 kilometers, what would you say? Yeah. So those are things that are more important conceptually to understand than just memorize it. Where's my phone? So you tell me what you want to do. I mean, measurements are actually...
measurements, as long as you have, like, do they give you the...
That's why I say some of the easy ones they may not give you.
Like,
Right.
do I have to know how many, like, in fluid ounces in the metric, like, you know what I mean?
Yeah.
Do I have to memorize that?
You know what, I actually don't know the answer, and I'll find out for you. Yeah, I'll find out for you.
One of each, like.
Sure, sure.
Anh chị đấy thì đã khai được bao nhiêu Yes. We are the Yes. No, I get it cheaper. I get centimeter, millimeter.
Get the answer? Okay, let me get to you in a minute. Let's hold on. So, do you want to try some of the measurements just to see whether you know how to convert? But I think the thing that you want to know is K is 1,000, right? Right? So when I say how many
1,000. You know the 1,000.
So if you know that kilometers is 1,000, so then 2 kilometers is 2,000. 2,000 meters.
Okay.
Okay? So knowing that K means 1,000. Okay? So understanding that is K, and then there's also like cm, centimeter, meter, kilometer.
Wait.
And what is the relationship between those three?
They all have meters.
Well, they all meters, yes. Yes. Yes, that's very good. That's very good.
0.1,
So-
1,
so-
and 1,000.
So if I say 1 kilometer here, how many meters is that? 1,000. And how many centimeters is that?
10,000.
Because it's 10 times.
Nhưng mà nó mò của ta nên nó
Okay? Okay? So again, understanding, I use this word a lot, but that's actually a lot of mathematics. It's not so much memorizing, but it's understanding that from K to M is 1,000, and then from meter to centimeter is 10. No, it's 100. It's 100, thank you. Centimeter is 100. So actually there should be another zero here. Thank you for correcting. Wait, did I do that right?
Yeah.
Plus 2 0, right? Yeah. Yeah, 2 more 0. It's 100. So this relationship is 1,000. And then this relationship, well, I should go the other direction. This is 100. No, this is times 1,000 and times 100. Yeah. So from kilometer to meter is 1,000. From meter to centimeter is 100. Thank you. I almost forgot. Centimeter is 100. Some of it comes from the root of the word. Centi usually is like 100. Like century, 100. Yeah, century. So what do you want to do? I mean, yeah, go ahead.
Page 13.
Page numbers on this one?
Yeah.
Wow! No kidding, it's like so hard to figure it out. 13, okay.
Question 4.
4, wait, 4, where's 4?
Well,
4 is in the fourth question.
what's in the box?
Oh, what is in the box? Okay. Using the conversion chart, see how they give you the conversion chart? So the key is not that you memorize the chart, it's that you understand how to use the chart, right? So if you're given a chart, convert 30 miles per gallon to kilometers per hour. This is good, okay? All right? So you're given a table and you have a question that is very relaxed.
Man, this is that cross math. If you,
Yeah. That cross math.
well,
That's,
I like it.
I know,
I
the cross
use this,
math.
now, because I'm looking at it, I remember using this. We had to use this for,
Biology,
no,
chemistry,
what's the other one? Astronomy.
Ah.
Oh, I didn't like that.
Now,
Yep.
when I say 30 miles per gallon, what would I put at the bottom? 30 miles at the top and 1 gallon at the bottom,
Yep.
okay? And you will not hear me talk a lot about scaling, so you can do cross multiply, but the scaling is conceptually what you're doing, okay? So, and you want to make it into what? Kilometers, which makes sense,
Yeah.
to
Over liters.
liters, L. Okay, so we don't know what those numbers are. So how many, so for 1 mile is 1.6093 kilometers. So if you have 30 miles, what do I have to do?
Times
Times
35 is
five.
1.6.
Yeah, so I'm gonna have to multiply by 1.6093. And what is that number if you do that? Somebody do that? I know.
Now you gotta use the calculator, somebody.
Well, it's gonna be roughly about
About
40,
40.
46 or something.
Cause a little over.
Yeah. How did I know that it's more than 45? How did I do that?
1/2, you look at that 1/2.
Or I multiply by 1.5, right?
Yeah.
If I multiply by 1.5, that means 30, 1 time will be 30, half of it will be 15, so I know the answer is over 45. 48.279. Now, so I don't quite understand on these problems for MTLE, how they do this. Again, it might be that you have to estimate, right? Like they could give you a number like that, and then they give you a number that is like 42, right? 42.782, right? Or then they give you a number that is like 67.8, blah, 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 all right? And I know it couldn't be the one before because it's too small. And it couldn't be the 60 something because then it's too big. So sometimes it's not so much that, oh my God, I'm gonna have to do this decimal and get the answer. But it's about estimating roughly what that number is, okay? I know it's bigger than 45. How do I know the other end? Like if I make this into 2, what would the answer be? 60. So I know, think about it, right? 30 times 1.5 would be 45, right? 30 times 5 times 2, because these are simple numbers.
Yeah.
It's 60. So therefore, look at that. See, I don't need to multiply it. 1.6 whatever 092. I know the answer has to be between 45 and 60. And it's probably closer to which one? Is it going to be closer to 45 or 60?
45.
Yeah, because this is only a little bit more than 1.5. This is the logic that they want you to do. Because if you panic and you kind of go, oh my God, I'm going to have to put 1.093, and then I'm going to have to multiply 30, and then you make all the mistakes in multiplying this, right? We all have been there, right? That's what you would do. I know a lot of you are going to do that. And I'm asking you to, maybe you don't have to.
What if they give you 49.2? Then you're gonna have to do that way because the math will go.
Maybe, yeah. You might have to do a little bit, right? But I don't think they will. But I might be wrong.
Finished it yet, anyway.
Huh?
People just never give us.
Right, we haven't finished the problem. We haven't finished the problem.
Yeah.
So 1 gallon, what is the relationship in 1 gallon to liter?
3.7854.
3.785.
Yeah, so I have to multiply 3.7854. Oh my goodness. All right. Oh, but this is
What's the
easy
same?
because it's 1 gallon.
Yeah.
Yeah.
So that's easy. So it's just 3.7854.
Yeah.
Right?
Yeah, so this is.
Right?
The same thing.
All right. Now,
And
we're not done, right? We're not done,
Or not?
right? Because what it says is that this is called a rate. Do you know that term? A rate means that something that is over 1, like 30 miles per gallon. So what they want you to do is to make this into 1 at the bottom, right? How many kilometers per 1 liter? So what do you do with these two numbers?
Divide.
Divide, right? So again, roughly, I'm going to do roughly.
So you're gonna divide like by 3.7 so that it gets the liter to 1?
Can you just do 15 times 3, and that's 45, and then find the closest answer?
Yeah, I mean, for me, 48, so this is close to 50,
I know.
right? Close to 50, this is close to 4, 50 divided by 4, what is that? That's a little bit easy to do. Or maybe 48 divided by 4, right? If you go 48 divided by 4,
Yeah.
that's 16. So I know my answer is about
16-ish.
16-ish.
Okay.
Again, when it is a problem like that, I don't think they're asking you to do every
12.
decimal. This
It's
is
12.75.
12.
It's 12, not
Oh,
16.
thank you.
12.
I was like, wait, what?
Wow, I did that. That's right. I always tell students, I say, I
Who
did
was
that on
paying
purpose.
attention?
They seem to pay attention, right? Students pay attention. Or there are times when I'm going, oh my God, I did actually make a mistake, and it's okay. Actually, I always tell my students, especially in math, you don't have to feel like you're the expert. You can do the problem with them and learn with them, okay? In fact, that's true with every subject, right? Teachers are not like dumping all the knowledge to them, right? It's about like creating an environment where they can learn, and you can learn a lot. Do we know what the answer is? This is not, see, this one is not a multiple choice, so this one doesn't really help me, right? So a lot of this problem actually doesn't help me because they are not multiple choice. So you're just practicing. You're just practicing. You could try to estimate and then get the real answer using a calculator, just so that you can practice estimating. So what is the answer when you actually do it?
12.754.
Wow, look at that. 12.754. Yep. 12.754. So you know that it was in the 12 ballpark. Now, how do I know whether it should be bigger than 12 or less than 12? Let's think about it. Let's think about that. Because they might trick you and give you something like, like some closer than 12 and some closer than 13. So let's do what we did here. So 48 is closer to 48 divided by 4, right? We know is 12, right?
Yeah.
This is pretty close to 48. Right? So then when I say 48 divided by 3.78, do you think the answer will be greater than 12 or less than 12?
Less than 12.
Hold on, no, that's
Right,
gonna
think
be
about it.
greater.
Think about it.
Before.
Think about money.
48
I love it. Think about money. If I have $48 and I divide by 4 buckets, I get 12. But if I divide by less than 4 buckets, will I get more or less?
You get more.
More. Yeah, you get a little bit more.
You get a little bit more, right? When you divide by something smaller, you get a little bit bigger number. So that might be another way to know, I know my answer is bigger than 12 and not less than 12. Okay. Right? Right? So those are logically where they will trick you by giving you several ones where one is 11.6 something and another one is 12.75 or something, right? And you know that it's close to 12, but which one? Which one? That's when I start writing this down. Like even I have to write this down to kind of logically say, if I have this divided by 4 is 12,